Hi, today's lesson is all about drilling and how we can extract fluid resources from either underground or, more challengingly, under the sea. We're working in our Theme 4B booklets. We're working on pages 18, 19 and 20. I'd like you to read through these pages first because there's a lot of information there about these different types of rig and about how we actually go about drilling through rock. We can then have a go at the type of job a geologist supervising drilling might be asked to do. To actually work out a time to actually drill what's a substantial borehole down into an oil reservoir. You can see the borehole is nearly 3,000 meters deep, but there's plenty of rock to get through. Have a go at question 8 on page 19 of your booklet. Remember that the softer rocks we can drill through 300 meters a day, the harder rocks only 10 meters a day. How long is it going to take us to make that hole? And also, particularly if you're drilling in somewhere like the northern North Sea, the weather's going to be pretty terrible a good chunk of the time. How can you factor in time lost to the weather into those plans? Something else to think about is the cost of this as well. A semi-submersible rig can cost $381,000 a day. A jack-up rig, which you can only use in shallow water, remember, is a bit less, but still $146,000 a day. There's a lot of money at stake here. Your calculations need to be accurate. Once you've had a go at that, have a read through the information all about hydraulic fracturing, or this process is called fracking. There's a lot of nonsense spoken about fracking. You'll find, if you do an internet search, all sorts of horror stories about poorly done fracking. It's a technique that geologists have been using for quite some time. And in recent years is being used to extract resources that in the past weren't accessible, because particularly gas was stored in impermeable rock. So fracking is a way of generating permeability. Now, I'd like you to try and weigh up the benefits and drawbacks of this as a technique, but I'd like you to base it on the science. So watch the BGS video. I'll include a link in the email to see really the reality behind fracking. And can you identify what's good about it and what's potentially bad about it? So this is the time to press pause and have a go at those questions on pages 19 and 20 in your booklets. See what you can come up with. Okay then, let's look at some answers. So first of all, if we look at our drill hole. Now, if we add up the rocks of different types here, we can see that there's about 2,700 meters of these softer rocks and another 200 meters of harder rocks. So if we divide this up, If we can do 300 metres a day, 2,700 metres of drilling are going to take us 9 days. For 200 metres of harder rock, they're going to take 10 metres, or take a day to do 10 metres, should I say. That's going to be a total of 20 days. So the drilling of this borehole should take 29 days. However, in some areas, drilling is going to be made very difficult because of the weather. So if we have maybe 90 days a year, that's about a quarter of a year. So drilling plans then need to be 4 times as long as actual drilling. Maybe up to 116 days for this hole. Remember the cost of these drilling rigs as well. It's a very expensive business. Obviously, though, the plan you would make would be seasonal. If you were doing that in the summer, you might get more good drilling days. In the winter, it might even be less. If we think about this idea of fracking, then, there are some benefits from this. It does increase productivity of oil and gas. We can get hydrocarbons out of the ground that previously we couldn't. So new oil resources and new gas resources are available as a result. The effect of that on people is that the price of oil and gas will reduce. Energy becomes cheaper. This can also extend the life of existing oil fields. So with infrastructure already in place, this could keep those oil fields, keep the jobs perhaps that go with those going longer. And finally, this can also increase energy security for a country to be able to produce its own energy rather than being reliant on other places. For example, the fact that in Britain, our gas supply is dependent on gas being imported from Qatar to a really quite a large degree. There are drawbacks to this, of course. This method does use a large amount of water. Groundwater could get polluted by chemicals, although it does depend on the depth that you are actually fracking at. Groundwater that we use for public supply is quite shallow. Groundwater at depth, maybe 800 meters down and more, is going to be very saline and really unusable. It can have an effect on making some oil fields unprofitable. Some countries perhaps that have expensive oil to extract have suddenly found themselves in financially dire straits because of cheaper hydrocarbons that are now available through fracking, especially in North America. Of course, cheaper prices for hydrocarbons increases their consumption, with the knock-on climate change impacts of this. And it can lead to increased drilling activity. Notice in none of those drawbacks do I talk about earthquakes. There's a lot of scare stories about earthquakes, but any earthquakes caused by fracking are tiny. They're on a level of a HGV truck passing. It really isn't a significant issue. Okay, so we've seen how we actually drill for hydrocarbons, and then some of the issues and some of the opportunities that can provide. What we need to do next time is think about how we could actually use these ideas and use this technology and this incredible engineering that we've used to get hydrocarbons out of the ground to be able to put the consequences of that using that energy back into the ground. But that's for another lesson. I'll see you then.